Hello friends, welcome to Urban Academy. In the last lecture, we have started the discussion on the central orbit. So in this particular lecture, we will discuss problems on the central orbit. Okay, so first we will revise the important formulas that we have discussed in the topic of central orbit. After that, we will move on. Okay, so what we have seen in the previous set of lecture is that the differential equation of the central orbit is represented in can be represented in polar form as well as in the pedal form. Okay, so in the polar form, which we have represented it as d2u upon d theta square plus u is equal to p upon h square u square. This is polar form. Okay, where p is the central acceleration that is assumed to be attractive. Okay, and u is equal to 1 upon r. This we have discussed. And in pedal form, we have the central acceleration is equal to h square upon p cube and dp upon dr. Okay, and r is the distance of the point from the pole. Suppose we have taken this point as the pole. This point is our this is our point. Okay, so this is r. So r is the distance and this is our pole. So r is the distance of this point. Suppose this is r comma theta. This is the distance of this point. R is the distance of the point P from the pole. Okay. And this we have already discussed, and the linear velocity at any point on the path of central orbit is given by this particular expression. So let us start solving questions. So what is given in question number 1? So we have find the law of force towards the pole under which the following curves are described. So the curve is given as AU is equal to e to the power n theta. Okay, so we have the differential equation of the central orbit is given by in polar form d2u upon d theta square plus u is equal to p upon h square u square, where p is the central acceleration. Central acceleration. Okay, so we have the expression as AU is equal to e to the power n theta. So let us differentiate this. Differentiate. Let us take this as equation 1. Differentiate equation 1 with respect to theta. So we have a du upon d theta is equal to n into e to the power n theta. Okay, so from here we have du upon d theta is equal to n into e to the power n theta upon a. Let us further differentiate this. So we have d2u upon d theta square is equal to n upon a into n times of e to the power n theta. And we have from here we have from equation 1 we have e to the power n theta upon a is equal to u. E to the power n theta upon a is equal to u. So we have n square upon a, sorry, n square into d2u upon d theta square, d2u upon d theta square is equal to n square into e to the power n theta upon a. And from here we have e to the power n theta upon a as u. So this is n square into u. Okay, so let us put this in the differential equation of the central orbit. So we have the differential equation of central orbit as this. So we have d2u upon d theta square plus u is equal to capital P upon h square u square. So we have the value of d2u upon d theta square as n square u. This is equation 2. So n square u plus u is equal to p upon h square u square. So we have p upon h square u square is equal to u into h square plus 1. Okay, so we have p is equal to h square u cube n square plus 1, and we have u is equal to 1 upon r. So we have p is equal to h square n square plus 1 upon r cube. So from here we have the p is proportional to 1 upon r cube. So we have the acceleration is proportional to the cube of distance from the pole. Let us write this. So what is the law of force? Law of force. Law of force is P is proportional to 1 upon r cube. That is, acceleration is proportional, is inversely proportional, is inversely proportional to the cube of distance of point from the. Okay, let us discuss part 2 of this question. So we have r is equal to a e to the power theta cot of alpha. So we have r is equal to 1 upon u is equal to a e to the power theta cot alpha. So we have u is equal to 1 upon a e to the power minus theta cot alpha. So we have du upon d theta is equal to 1 upon a into e to the power minus theta cot alpha to minus cot alpha. So we have du upon d theta is equal to, and this value is u from here. Let us put it here. So let us put the value of u here. So we have minus u cot alpha. So we have d2u upon d theta square is equal to minus cot alpha into du upon d theta. Okay, and du upon d theta is minus u cot alpha. This is equal to minus cot alpha into minus u cot alpha. So we have this as d2u upon d theta square is equal to u cot square alpha. So let us write down the differential equation of the central orbit. So the differential equation of central orbit in polar form is given by d2u upon d theta square plus u is equal to p upon h square u square. So we have this value as u cot square alpha plus u is equal to p upon h square u square. So we have u of 1 plus cot square alpha is equal to p upon h square u square. From here u for sec square alpha is equal to p upon h square u square. From here we have p is equal to h square u cube cosec square alpha. So we have p is equal to h square cosec square alpha upon r cube because we have u is equal to 1 upon. So p is this value. So here also p is inversely proportional to r cube. So acceleration is inversely proportional to the cube of distance of point from pole. Okay, so let us discuss question number 2. How we can solve this? So we have the equation as r to the power n is equal to a to the power n cos of n theta. Okay, and we have r is equal to 1 upon u. So let us place this 1 upon u to the power n is equal to a to the power n cos of n theta. So from here we have a to the power n u to the power n is equal to, we can write cos n theta as 1 upon sec n theta. This is sec of n theta. Okay, so this is equation 1, this is equation 2. Okay, so let us take log both sides, taking log both sides. So we have n log a plus n of log u is equal to log of sec n theta. So from here we have, let us differentiate both sides with respect to theta. Okay, so we have n of 1 upon u du upon d theta is equal to 1 upon sec of n theta into sec of n theta into tan n theta. Okay, so differentiation of sec of n theta is sec x tan x. So we have sec n theta tan n theta into n. N gets cancelled and sec n theta gets cancelled. So du upon d theta is equal to u of tan n theta. Okay, so we have du upon d theta is equal to u tan of n theta. So let us further differentiate this. Okay, so we have also we have a to the power n u to the power n is equal to sec of n theta. This is equation 2. So I am writing it separately because I will use it at the later stage. Okay, now let us differentiate du upon d theta with respect to theta further. Okay, so we have d2u upon d theta square is equal to u times of n of sec square n theta plus du upon d theta into tan of n theta. So we have u of n sec square n theta plus du upon d theta is u tan n theta. So u tan square n theta. This is d2u upon d theta square. Okay, so now we have the differential equation for the central orbit in polar form as differential equation for central orbit in polar form as d2u upon d theta square plus u is equal to p upon h square u square. So from here we have u plus un sec square n theta plus u tan square n theta is equal to p upon h square u square. So we have this as u times of 1 plus tan square n theta plus un sec square n theta is equal to p upon h square u square. Let us further simplify this. So we have u of 1 plus tan square n theta is sec square n theta plus un sec square n theta is equal to p upon h square u square. 1 plus n u times of sec square n theta is equal to p upon h square u square. So from here we have p is equal to h square. U square is here and u is here. So u cube 1 plus n into sec square n theta, and sec n theta is a n a to the power n u to the power n. So a to the power n u to the power n of whole square. Okay, so let us further simplify this. So we have the central acceleration p as p is equal to h square. Here we have u cube 1 plus n into a to the power 2n and u to the power 2n. So we have p is equal to h square into 1 plus n u to the power 2n plus 3 into a to the power 2n. So we have the central acceleration p is equal to h square 1 plus n into a to the power 2n upon r to the power of 2n plus 3. So we have the central acceleration is inversely proportional to r to the power 2n plus 3. Okay. So we have the central acceleration. So we have the central acceleration. Central acceleration is inversely proportional to the 2n plus 3th power of distance of point from pole. Okay, so this is our law of force. Let us solve question number 3. How we can solve this? So we have the curve is r square is equal to a square cos of 2 theta. Okay, so for the curve r to the power n is equal to a to the power n cos of n theta, the law of force is P is um, proportional to 1 upon r to the power of 2n plus 3. Okay, so this is the law of force for the curve given by this expression. R to the power n is equal to a to the power n cos of n theta. Okay, so let us put n is equal to 2 here. So we have r square is equal to a square cos of 2 theta. So the law of force will be, let us put n is equal to 2 in this particular expression. So P is inversely proportional to r to the power of 2 into 2 plus 3. So P is inversely proportional to r to the power 7. Okay, so the central acceleration is inversely proportional to seventh power of distance of point from pole. From pole. Okay, let us discuss question number 4. How we can solve this? The law of force towards the pole under which the curve r to the power n cos of n theta is equal to a to the power n is described. How we can solve this? So let us. So we have r is equal to 1 upon u. So we have 1 upon u to the power n cos of n theta is equal to a to the power n. So we have a to the power n u to the power n is equal to cos of n theta. So let us take log both sides. So we have n log a plus n log of u is equal to log of cos of n theta. Okay, so let us differentiate this with respect to theta. This gets vanished because it is a constant. Okay, So we have n into 1 upon u du upon d theta is equal to 1 upon cos of n theta into n times of minus sin n theta. Okay, so n gets cancelled. So we have du upon d theta is equal to minus u tan n theta. Okay, so we have du upon d theta is equal to minus u tan n theta. Okay, so now let us further differentiate this. So we have d2u upon d theta square is equal to minus of du upon d theta into tan n theta plus u times of tan n theta. This is n times of sec square n theta. Okay, and we have du upon d theta is minus u tan n theta. Okay, so let us put this value here. Okay, so let us further simplify this. Also we have, let us write down here, we have a to the power n u to the power n is cos of n. This we will use at the later stage. Okay, so let us further simplify this. So we have d2u upon d theta square is equal to minus of du upon d theta is minus u tan square n theta plus un sec square n theta. Okay, so we have d2u upon d theta square is equal to u tan square n theta minus un sec square n theta. Okay, so now let us write down the differential equation of the central orbit. Okay, so we have the differential equation of central orbit. Central orbit as we have d2u upon d theta square plus u is equal to p upon h square u square. So we have p upon h square u square is equal to um, u plus, this is d2u upon d theta square is this expression. So u plus u tan square n theta minus un sec square n theta. Let us further simplify this. So we have p upon h square u square is equal to, you can take this as u common, so 1 plus tan square n theta minus un sec square n theta. So we have p upon h square u square is equal to u of 1 plus tan square n theta is sec square n theta minus un sec square n theta. So we have u of 1 minus n sec square n theta. Okay, and h square u square, and this is our central acceleration. Let us further simplify this. So we have p is equal to h square 1 minus n u cube sec square n theta. So from here we have 1 upon cos of n theta is equal to a to the power minus n u to the power minus n. So we have sec of n theta is equal to a to the power minus n u to the power minus n. So from here we have minus a to the power minus n u to the power minus n ka square. Okay, so we have p is equal to h square 1 minus n u cube a to the power minus 2n u to the power minus 2n. So from here we have p is equal to h square 1 minus n u cube. Sorry, let us write down it. We have this as u to the power 3 and this is minus 2n into a to the power minus 2n. Okay, so let us further simplify this. So we have p is equal to h square 1 minus n into upon a to the power 2n into with this we can write as u to the power minus 1 2n minus 3, this we can write. Okay, so we have r is equal to 1 upon u, r is equal to u to the power minus 1. So this we can write u to the power minus 1 is r. So let us replace this. So we have p is equal to h square 1 minus n upon a to the power 2n into r to the power 2n minus 3. So we have the law of force as p is proportional to r to the power 2n minus 3. This is the law of force for r to the power n cos n theta is equal to a to the power n. Okay. So let us discuss question number 5. How we can solve this? A particle describes a curve r to the power n is equal to a cos of n theta plus b of sin n theta under the force to the pole. Find the law of force. So let us assume a is equal to k cos of alpha and b is equal to k sin of alpha. Okay, so r to the power n is equal to k cos alpha cos of n theta plus k sin alpha sin n theta. Okay, so we have r to the power n is equal to k common cos alpha cos n theta plus sin alpha sin n theta. So this is equal to k times of cos of n theta minus alpha. This we can write as, okay. Let us use the deduction of cos a minus b. Okay. So from here we have let us put r is equal to 1 upon u. So this is equal to 1 upon u to the power n. Okay. So u to the power minus n is equal to k cos of n theta minus alpha. Okay. So this we can further write as uh, k u to the power n is equal to sec of n theta minus alpha. Okay. So let us take log both sides. So we have log of k plus n log of u equal to log of sec n theta minus alpha. Okay, so we have, let us differentiate this with respect to theta. So n into 1 upon u du upon d theta is equal to 1 upon sec of n theta minus alpha into differentiation of sec n theta minus alpha is sec of n theta minus alpha into tan n theta minus alpha into n. So this gets cancelled and this gets cancelled. So we have du upon d theta equal to u tan of n theta minus alpha. Okay, so we have du upon d theta is equal to u tan n theta minus alpha, and we have sec of n theta minus alpha is equal to k u to the power n. Okay, so let us further differentiate this du upon d theta. So we have du upon d theta is equal to u tan of n theta minus alpha. So d2u upon d theta square is equal to du upon d theta into tan of n theta minus alpha plus u times of n into sec square n theta minus alpha. Okay, so let us put the value of du upon d theta. So we have d2u upon d theta square is equal to, we have du upon d theta as this expression. So u tan square n theta minus alpha uh, plus u n sec square n theta minus alpha. Okay, so we have the differential equation of central orbit as d2u upon d theta square plus u is equal to p upon h square u square. Okay, so we have this as, let us further simplify this. So we have d2u upon d theta square as this expression. So we have d2u upon d theta square plus u is equal to p upon h square u square. So p upon h square u square is equal to u tan square n theta minus alpha plus u n sec square n theta minus alpha plus u. Okay, so we have this as, let us take u common. So we have p upon h square u square is equal to u times of 1 plus tan square and theta minus alpha plus un sec square and theta minus alpha. So we have u of sec square and theta minus alpha plus un sec square and theta minus alpha. So we have u times of 1 plus n sec square and theta minus alpha. This is p upon h square u square. P is equal to h square u cube 1 plus n into we have sec of n theta minus alpha is k u to the power n. So this is k u to the power n ka whole square. So let us further simplify this. Okay, so we have p is equal to h square u cube 1 plus n into k square u to the power 2n. So p is equal to h square 1 plus n into k square u to the power 2n plus 3. Okay, so let us further simplify this. So we have p is equal to h square 1 plus n into k square upon r to the power 2n plus 2. We have u is equal to 1 upon r. So p is inversely proportional to r to the power 2n plus 3. Okay, so we have the law of force as p is inversely proportional to r to the power 2n plus 3. Therefore, central acceleration is inversely proportional to 2n plus 3th power of distance of point from pole. Okay, so let us discuss question number 6. Okay, a particle describes a circle pole on its circumference under the force p to the pole. Find the law of force. Okay, so we have the circle like this. Okay, and we have radius as a. So this whole length will be 2a, and we have the pole on its circumference. Okay, so let us consider this on one of its diameter. Okay, so this is our pole. Let us consider a point P here. Okay, so let us take this distance as r. Okay, and this angle is theta. So this point will be 2a cos of theta, and we have this point as theta is equal to 0. So this point will be 2a into cos of 0 degree. So this is 2a. This point will be 2a. Okay, so we have the curve as r is equal to 2a cos of theta. Okay, and we have r is equal to 1 upon u. So let us put here 1 upon u is equal to 2a cos theta. Let us take log both sides. So log of 1 upon u is equal to log of 2a plus log of cos theta. Okay, so from here we have minus log of u is equal to log of 2a plus log of cos theta. Let us differentiate this expression with this equation. Let us take this as 1, this as 1, this is 2, and this is 3. So let us differentiate equation 3 with respect to theta. So we have minus 1 upon u into du upon d theta is equal to 0. Log 2a is constant plus 1 upon cos theta into minus of sin theta. So we have du upon d theta is equal to u tan theta. Okay, so we have du upon d theta is equal to u tan theta. Let us further differentiate this. Okay, so let us further differentiate du upon d theta. So we have d2u upon d theta square is equal to du upon d theta into tan theta plus u into sec square theta. Okay, so now we have the differential equation of central orbit in polar form. So we have d2u upon d theta square plus u is equal to p upon h square u. So P upon H square U square is equal to d2U upon d theta square is, let us put du upon d theta here. So this is U tan square theta plus U sec square theta. Okay, plus U. So this will be equal to U times of, let us take U common, this is 1 plus tan square theta. This will be U sec square theta plus U sec square theta. This is 2U sec square theta. This is P upon H square U square. Okay, let us further simplify this. So we have P upon H square U square is equal to, let us further simplify this. So we have P upon H square U square is equal to 2U sec square theta. So we have P is equal to 2 H square U cube sec square theta. So from here we have sec theta. From here we have 1 upon U is equal to 2A cos theta. So sec theta is equal to 2AU. Okay. So we have P is equal to 2H square U cube into 2AU का whole square. Okay. So let us further simplify this. So we have P is equal to 2H square U cube into 4A square U square. So we have P is equal to 8H square U to the power of 5. So from here we have P is equal to, let us put U is equal to, and we have A square also here, no? This is A square. So we have P is equal to 8A square H square upon R to the power of 5. Okay, because we have U is equal to 1 upon R. This is, so the law of force will be P is inversely proportional to R to the power 5. So we have the central acceleration. Central acceleration is inversely proportional proportional to fifth power of distance distance of point from pole. Okay, so we will discuss further questions in next particular lecture. Thank you.